Okay, so in the last class, we had a discussion regarding the disaster and vulnerability profile of our country. I'd like to continue with the same class, and then today we are going to see the particular disasters of floods and then earthquakes, landslides, cyclones. So, which are the parts of the country which are mostly affected by these disasters in India. But before we do that, uh, I would like to show you one video that is showing the various ranges of uh, mountains and the hills which are instrumental in affecting many of the geographical features of the country. Particularly the hills which are in the peninsular region. So, like in the last class where I introduced to you the different rivers, in this class here, I would like to start with the various hills and then the mountains which are there in our country. So, let us start with the video first.
In this video, we are going to look at the mountains of Peninsular India. There are a lot of people who get confused between Deccan Plateau and Peninsular Plateau. I'll clear the confusion first. The Peninsular Plateau is this entire landmass which is called India today. Originally, it was part of the ancient continent of Gondwana. And you know the story how the Indian plate broke away and started drifting towards north when it finally merged with the Eurasian plate. And the consequences of that plate movement, as we know, is the formation of the Himalayan mountains. So plateau is basically a highland with a flat terrain of land. If you exclude the Himalayan mountains, everything before that is part of the Peninsular Plateau. This entire region. Now within this Peninsular Plateau, the southern portion, which is roughly from this region to the southern tip of India, is called the Deccan Plateau. The Peninsular Plateau is divided into two parts, the Central Highlands and the Deccan Plateau. I've shown you where the Deccan Plateau is, and the rest of it is the Central Highlands. In this video, we're going to look at the main mountains of Peninsular India. First, we'll look at the Aravalli Range. These mountain ranges run towards the southwest direction, starting in North India from Delhi and passing through southern Haryana, through the western India across the states of Rajasthan and ending in Palanpur in Gujarat. The Aravalli Range are the oldest fold mountains in India. Guru Shikhar near Mount Abu, Rajasthan is the highest peak of Aravalli Range with an elevation of 1772 meters above sea level. Now we will look at the Vindhya and Satpura ranges. They form the northern border of South India or the Deccan Plateau. Satpura range rises in eastern Gujarat, running east through the northern border of Maharashtra and southern region of Madhya Pradesh till Chhattisgarh. In Chhattisgarh, you will find another set of hills called the Maikal Hills, which are also called the eastern part of Satpura range. But the land elevation is from east to west direction. That is the reason Narmada and Tapi river flow to the west and drains into the Arabian Sea. Mount Dhupgarh is the highest point in the Satpura range and it is in Madhya Pradesh, located in a place called Panchmarhi. It has an elevation of 1350 meters. It is the highest point of Madhya Pradesh. If you look at the Vindhya ranges, it also originates near the eastern border of Gujarat and then it runs along the state border of South Rajasthan, North Madhya Pradesh, South Uttar Pradesh, North Chhattisgarh and South Bihar. Even here the land elevation is from east to west direction. Now that you know the location of Vindhya and Satpura ranges, you can easily imagine that the cities of Bhopal and Indore lie on the plain area in between of Satpura and Vindhya range. Kalumar Peak is the highest peak of Vindhya range, located in the Damoh district of Madhya Pradesh. It has an elevation of 752 meters above sea level. As I have said, Narmada and Tapi or Tapti are the two rivers that flow in the Arabian Sea. Narmada River flows in between Satpura and Vindhya range, whereas the river Tapi flows south of the Satpura range, near to the northern part of Maharashtra. If you go to the western coast, you will find a long chain of continuous mountains called the Western Ghats. They run parallel to the Arabian Sea and stretches across the western coastal states of South Gujarat, Maharashtra, Goa, Karnataka, Kerala, and Tamil Nadu. In the states of Maharashtra and Karnataka, Western Ghats is also known as Sahyadri. The Western Ghats are also the first highlands of India that encounters the southwest monsoon winds. That means this region receives a lot of rainfall, due to which you will find tropical evergreen forest. Therefore, it also has an exceptionally high level of biological diversity, and it is also recognized as one of the world's biological hotspots. If you go to the eastern coast, you will find a discontinuous range of mountains called the Eastern Ghats that run through northern Odisha, Andhra Pradesh, and Tamil Nadu. In between Andhra Pradesh and Tamil Nadu, these mountains do exist in some of the southeastern parts of Karnataka and northeastern parts of Kerala. Basically, this region over here. It is called the Nilgiris, where the Western Ghats and the Eastern Ghats meet. As we know, most of the rivers in Deccan Plateau drain into the Bay of Bengal. That is why you will find the discontinuity in the mountains of the Eastern Ghats, because the rivers erode and cut the mountains while flowing into the Bay of Bengal. Annaimudi is the highest peak of the Western Ghats, with a height of 2695 meters, and is also the highest point in the entire Peninsula India. It is located at the border of Kerala and Tamil Nadu. In the Eastern Ghats, Armakonda is the highest peak with a height of 1680 meters, which is located in the Araku Valley of northern part of Andhra Pradesh. If you notice their locations, you will learn that the height of the Western Ghats progressively increases from north to south, whereas the height of Eastern Ghats increases from south to north. Another important point that you have to understand is that the Deccan Plateau is slightly tilted towards east. In other words, the land elevation of the Western Ghats is a little higher than the Eastern Ghats. Eastern Ghats have gone through a lot of erosional activities, which has created this natural land slope for the rivers to flow into the Bay of Bengal. So these were the important mountains of Peninsular India. These mountains not only form the catchment area for many peninsular rivers in India, but they also play an important role in affecting the climate of nearby lands. I hope this video was informative. Let me know your thoughts in the comment section. Thanks for watching, and I'll see you in the next one.
Okay, so that was regarding the mountain ranges in the peninsular region of our country. But apart from that, do you know what range is there in the northeastern part of the country, especially in Arunachal Pradesh or Sikkim or parts of Uttarakhand? What is this range known as? Yes, anyone?
Himalaya.
Yes, it is the Himalayan range, and also this is known as there is a sub subsection of that. Have you heard about the Sivalik ranges?
So,
Yeah, so this is a part of the Sivalik range, which also runs from uh, the, the the plains of northeast and starting from Himachal Pradesh up to Sikkim and then parts in Arunachal Pradesh. So in geological age, if you compare this range, it is in geological age, these hills or mountains are actually younger compared to the Aravalli region or the Satpura region of mountains. So that is one of the reasons you probably have noticed if you are living in this area that you will see that there are a lot of mm, uh, formation that is still happening in the hills of the Sivalik ranges even of today. So in compared to the geological age, these mountain ranges are much younger. If you have noticed it, that there would be a lot of rocks which are still forming in these mountain ranges, and these rocks are very brittle. By saying so, it means that with a minute observation, you must be noticing that there are a lot of branches of trees or shrubs which you will find sprouting out from these rocks inside of the rocks. And then these rocks actually undergo a lot of wind abrasion. That means due to the actions of the wind, there is a lot of erosion that happens in this part of the rocks. So this range is naturally prone to wind abrasion and erosion compared to the rocks in the other parts of the country. Okay, so that is one of the
So,
reasons. Yeah.
uh, what is no, Sivalik Hill and then Himalayan range? A little bit confused, sir.
No, the Sivalik range actually extends from the Himalayan range. That itself is the Himalayan range, part of the Himalayan range. That itself is a part of the Himalayan range.
Do Sivalik range include Arunachal?
Yes, that extends up till northeast part of the country. So as I said, geologically, these mountains ranges are younger than a lot of formation of the rocks that you will still observe in these ranges. And that is precisely the reason that these rocks undergo a lot of abrasion, wind abrasion and erosion. And that is one of the reasons that these uh, rivers, which are flowing through these mountain ranges, they carry a lot of sediments in terms of, how to say, uh, sand particles and then also silts. So if you look at the tributaries of the Brahmaputra or even the Brahmaputra river itself, one of the reasons that it carries a lot of sediments is that the tributaries are contributing a lot of sediments in the water itself. Okay, so that is very important in order for you, so that you have a little background about the physiographic uh, idea of the rocks, the mountains and the hills in the country itself. As it was shown in the earlier video, you see the Aravalli range is much older. Okay. Okay, let us come back to this slide where we are going to show precisely something related to the flood hazard profile of the country. So these are the areas. See a lot of floods mostly happening. So which are the areas? The areas highlighted in the orange color in the map. So if you look with a minded observation, you will see that these areas are again the same areas which are falling into the floodplains of the major rivers, which we have discussed or where we have seen in our videos. So these rivers include the rivers of Ganga, then in the northeastern part Brahmaputra, and then some of the peninsular rivers such as Godavari, Krishna, Mahanadi, and these rivers, and then rivers which are there in Gujarat and Rajasthan. So you will be you will be amazed to know that flood occurs in the western parts of the country itself, and these floods are the riverine floods. Also, you see the floods occurring in parts of Himachal Pradesh, Haryana, Punjab, and Bihar, and West Bengal. So these are the riverine floods. So these floods are seasonal in nature. That means during the progression of the year, monsoon sets in, and then these river waters are filled up, overflows the banks, and then the flood-prone areas are actually shown here. So this is a cumulative kind of a map. It is not exactly a map of particular year, but it has been happening for almost all the years in past history. There may be exceptions from this map also, but in general, this flood hazard map is an idea of the greater India. Again, it's written that India is one of the most cloud-prone countries in the world. The average rainfall in India is 1,150 millimeter, with a significant variation across the country. And then these variations are coming due to the existence of these mountain ranges and then the southwest monsoon. As you saw in the earlier video, that because of the Western Ghats, the western part of the country, and then again the southwestern part of the country, including the states of Karnataka, Kerala, Goa, these kind of states, they receive a lot of monsoon rain. Okay, so it also happens in our states as well, towards the northeastern states. The annual rainfall along the western coast and then the western Ghats, Khasi Hills, and then over most of the Brahmaputra Valley amounts to more than 2,500 millimeters. So it says that on an average, this annual rainfall is about 1,150 mm, but there are places where you will see extreme precipitation. So we do not have to go too far in order to know that where we have the highest rainfall in, where is the highest rainfall in the world? Anyone from Meghalaya? Yes. Who is from Meghalaya in the group? Where do you see the highest rainfall in the world? Even anyone is not from Meghalaya, you should be knowing it because it is a part in the northeastern India. Where is it that you see or observe the highest?
Cherrapunji, sir.
Huh? Hello.
Cherrapunji.
Yes. So it's in Meghalaya, in parts in Cherrapunji, and then Mawsynram. So here you will see that the average annual rainfall, it goes somewhere above 2,500 millimeter basis. So it is very diverse in kinds of, or in respect to the total amount of rainfall, or you will see that the whole country is very diverse in case of temperatures, wind speed, or other climatological factors. And this has been contributed because we have so many mountains, ranges here. So most of the floods occurring in the monsoon periods are usually associated with the tropical storms or depressions. And then active monsoon conditions and break monsoon conditions, 23% or 25% of the states and union territories of the country are subject to floods. So you see that these floods are floods of rivers arising from the rivers as well as due to the floods of the tropical or subtropical depressions. Okay, and it amounts to around how much? 23 of the 35 states and union territories in the country. So they receive floods. And because of the floods, around 40 million hectares of land, and it goes to around roughly 1/8 of the country's geographical area is prone to floods. So you can say that India, on an average, may be experiencing about 12% of its geographical area due to the floods. And then, as I showed you in the first slide here, you see this is floods, so around 12% of the floods. So these floods also amount to floods in the river and then due to other monsoonal activities and then seasonal storms. Okay, then coming again to cyclone hazard. So someone was saying yesterday, or I think in the last class, so are we really affected by cyclones? So this map actually gives you a better understanding how various parts of the country are affected by cyclonic storms. This may be, again, I said that cyclone, here I am seeing cyclone or in general any wind depression. So normally when we call a cyclone, it should be originating somewhere here in the Bay of Bengal. So if it is not originating in the Bay of Bengal, normally it is not called cyclone, but this term is used in general here for any storm that may be occurring on the western part here, or that may be happening some other part and then again coming to the country. So it's mostly the storms or the wind hazard profile. So you see in the map that out of the whole country, some areas are uh, more risk prone, and then some areas have lesser amount of risk. So if it is an area with a higher risk, we see it in the dark blue color. So where are the dark blue colors? You see here on the on the east coast, starting from Tamil Nadu, then Andhra Pradesh, and then going to Odisha, and then coming to West Bengal. So this entire eastern coast is affected by a lot of cyclonic activities. And if you notice it a little bit minutely, you will see that this dark blue color is not extending too much into the land. So on an average, maybe this is around 100 or 150 kilometers. We do not have a scale here. I think there is a scale here. So in the scale, in the map, you see about from here to here, it is 100 kilometers. So from here up to the dark border, it is maybe less than 100 kilometers. So that means the cyclone may come anywhere in these coastal areas, and they can hit all these places, particularly in the coastal lines. And then by the time it starts to progress inside the country, the energy of the cyclone is normally uh, fading away. And that is why not up to maybe 100 kilometers of the land, we do not see these darker blue color areas. uh, and then inside the country, the western part also, Gujarat is affected by some of the cyclonic activities in the western part and maybe in the Arabian Sea. And then also some parts in Mizoram and Tripura, including Jammu and Kashmir. So you see the here it is categorized into one, two, three, four, five, six risk zones, and then in every risk zone, the average velocity or wind speed is recorded here. So roughly, if it is more than 55 meter per second, it is in the darker category areas. So some of the areas are actually free from, or you can say very low level of risk uh, from cyclonic or wind hazards. So which are the areas? You see these parts in Karnataka, and then in Madhya Pradesh, parts in Jammu, and then Himachal Pradesh, Rajasthan. We do not have this much, so many activities of the wind. Okay, so let me read out from this, whatever it is written. The major natural disaster that affects the coastal region of India is cyclone. And as India has a coastline of 7,516 kilometers, so you see, so this coastline is extending from this east up to the far western part. So wherever you have the ocean and the ocean is touching the land area, you have this entire coastline. So it is about 7,516 kilometers. So out of that much of a land, a length of coastline, about 5,700 kilometers prone to cyclones and tsunamis. So it is not only cyclones, but you have a risk from tsunamis as well. So that amounts to about 71%. Okay, and then most of the states which are affected by are Gujarat, Maharashtra, Goa, Karnataka, Kerala, Tamil Nadu, Pondicherry, Andhra Pradesh, Odisha, and West Bengal. So mostly all these coastal states. The island of Andaman, Nicobar, and Lakshadweep also are prone to cyclones. So these small, tiny islands in the Indian Ocean, they are also affected by these cyclonic activities. And it goes on. It says, on an average, about 5 or 6 tropical cyclones form in the Bay of Bengal and Arabian Sea. So either on the west east part or the west part. Uh, on an average, on a year, about 5 or 6 tropical storms form in the Bay of Bengal or Arabian Sea and hit the coast every year. So some of these cyclonic activities, even if they may form here, they do not come and hit. So the major form of cyclonic activities that are disruptive to the people living inside the country, on an average about 5 or 6 came. Out of these, 2 or 3 are severe. You see, a severe supercyclonic storm with a wind speed up to 250 kilometers per hour crossed the coast of Orissa on 29 October. So that was about the super cyclone that I was mentioning in the earlier lecture. It was way back in 1999. So since 1999, a lot of technological advancement has happened in the area of modeling the path of these cyclonic activities and also dissipating this information into the people who are living in these coastal areas. So since then, since 1999, India has advanced a lot in terms of early warning of cyclonic activities. So you will not believe that uh, in the after years of 1999, there also has been major cyclonic storms which were hitting the coastlines of Orissa, but the number of casualties are drastically reduced. One of the reasons is our efficient early warning systems. So this includes accurately predicting the path of the cyclone and uh, putting this information across to the people in advance of maybe 1 week, and then evacuating these people and uh, stopping the how to say the fishermen from venturing into the sea, particularly for those days. So in 1999, those things were not that advanced. That is why it was one of the reasons many casualties actually occurred at that time. Official record is 10,000, but people say it was amounting to more than 1 lakh. That was the unofficial record. It says also this may be the worst cyclonic storm of the country in Orissa and that region, responsible of as many as 10,000 deaths. So this is the official figure, but unofficially, it was much more. Okay, uh, so there is a classification of cyclonic disturbances uh, in the Indian Ocean. So when we actually call if it is a super cyclone or if it is a very just low pressure area. So there are categories, and then I have taken this from the source I mentioned below. Uh, it may be a little bit different in terms of the wind speed when it is in the ocean or if it is in the land. So uh, if the wind speed on an average in kilometer per hour, so kilometer per hour is recorded on land. So if there's less than 31, then we just call it a low pressure area. So it is not that a very significant thing happens. So same thing if it is in the ocean. So in ocean, we try to measure it in knots. Okay, knots, K-N-O-T. So please search in Google or just refer what is 1 knot. Then again, if it is between 131 to 49 kilometer per hour, and if it is happening in the land, we call it as a depression. That amounts or it is equivalent to 17 to around 27 knots. And slightly as you go down in this list, uh, the severity keeps on increasing. And then next is the deep depression. Then from here you see you can say it is a cyclonic storm. So in order for it to be a cyclonic storm, it has to be in the category of 34 to 47 knots, that is in the ocean. And then if it is, we have to call it a cyclonic storm on land, it has to be around 62 to 88 kilometer per hour. Then again, we crossed a severe cyclonic storm, which is higher, much higher than that. Then very severe cyclonic storm, you see, is increasing. And if it is more than 222 kilometer per hour, imagine 222 2 kilometers per hour is really something very extraordinary. And then we can categorize the storm as super cyclonic storm. So in history, there are not many instances of a super cyclonic storm. That is a good thing, but in the 1999 case in Orissa, the wind speed was around that time, around that much. So it was one of the recorded super cyclonic event. Okay. Apart from the wind speed, there are other factors which are also responsible for the total damage in the area. This is not only the wind speed, but wind speed is mostly the uh, major contributing factor. So what may be the other contributing factors? So it may include the amount of water or the dust that it brings with it and then dumps inside the land. And so again, you just try to have a look and then find by yourself what may be the other contributing factors apart from the wind speed in case of cyclonic activity. Okay. Okay. Then coming to another major, I'd say, hazard is the earthquake. So our country is affected by this earthquake hazard, or I'd say an earthquake disaster. Uh, and then the severity or the activity of earthquakes across the country is greatly varying from one part to another. In this case, everyone knows now. I hope you all know what actually is an earthquake. It is, in general terms or in plain terms, it is the shaking of the ground where we stand. And then uh, behind the mechanism, behind the reason why it shakes, uh, we will be confined, or we will be concentrating our fact that we are all drifting in some plates over the molten magma. Okay, and then these plates collide with each other, and then in this collision, uh, the energy is released in the lithosphere. So when the energy is released, this energy travels to the surface of the earth, and then we feel it. So mm, there are many, I would say, parameters with which earthquake is actually measured. Some of the significant parameters are the magnitude of the earthquake. Then we also hear about the intensity of the earthquake, or another parameter is known as the PGA, or it is also known as the peak ground acceleration. So all these are very important, especially for someone who is an earthquake engineer or a geologist. For you also, in order to know the differences, it's a little bit important. But people tend to confuse uh, quite often among these parameters. Two of the main parameters includes the magnitude and the intensity. So magnitude is here you see it in the small figure on the top right corner. The magnitude is an uh, absolute quantity. So it indicates the amount of energy that is released in an earthquake. So what are the units of energy? Remember, in physics, energy is measured in joules or kilojoules. Okay, so we measure it in that term, and then uh, it has nothing to do with whether you are near to the epicenter or you are far away from the epicenter. So, by saying so, that is absolute quantitative measurement of one of the parameters of an earthquake. So, it is also an indication that if the earthquake is small or if the earthquake is really big. But apart from the magnitude, how we feel the shake on the place that we stand is uh, another parameter we like to describe it with the intensity of the earthquake. So intensity is the strength of shaking of the earthquake. So by definition, magnitude is the measure of amount of strain energy released by the fault rupture. So if it is an earthquake because of the fault rupture, so for whatever reason the energy is released, it is the absolute measurement of the energy. On the other hand, the intensity of the earthquake at the place is a measure of the strength of shaking during the earthquake. And then you know that during the release of this energy, various kinds of waves actually propagate inside from the epicenter up to the place where you stand. So mostly there are three forms of waves. One is known as the P waves, which are the fastest waves, followed by the S waves, and then another one is known as the surface waves, rolling waves. So these waves, I'm not really going to explain you in detail, but they have different characteristics, and then the damage uh, caused by these various uh, waves are of different nature. Okay, so again, how is it measured? So it says intense magnitude is measured in a Richter scale. So you have often heard about Richter scale. So Richter scale is a logarithmic scale, and then you whatever sometimes you hear it often in the news that it's a Richter 5 magnitude earthquake or Richter 6 magnitude earthquake. So this is the amount of energy that is being released simply in the Richter scale. But how you are feeling on the ground, it is being given by normally two scales, but we often hear about the MMI scale, or it's known as the modified merciless intensity scale, and Medvedev, Schopenhauer, Karnik, MSK scale. So this is how you feel at the ground. Sometimes you just keep stable. That means your MMI or intensity is less, even maybe the magnitude is higher. So depending on how you feel the shaking, sometimes we try to connect uh, this with one similar kind of shaking intensities from one point to another, and try to find or try to connect dots on the ground, and then we come up with what is known as mm, the ISO shaking lines. On a way, you can, on the other hand, you can say it's contours of intensity. Okay? Then again, measurement based on it is based on the movement of this. So it is basically it is an absolute measurement. And then how you can categorize the intensity. In order to categorize the intensity, you'll have to look and do a survey. Okay, extent and type of damage. You'll have to go to the place and then see what kind of damage is being done. For calculating intensity of earthquake, the response of people in affected areas, damaged structures, and changes in natural surroundings are observed. So after the earthquake, people go and visit the areas and then see similar damages, and then they try to connect these controls of damages together, and then from there you get the MMI intensities of the place. The areas near to the epicenter are may feel extremely shaky, and then if you are far away from the epicenter, obviously you may feel less shaky. So near to the epicenter, maybe the intensities are higher. So effect of distance from the epicenter, it has no effect in terms of the magnitude, but in the MMI scale, as I said, if you were towards the epicenter, maybe you feel a little bit more. Then at the same time, you feel less. So here on the screen, you see which parts in India you have uh, the more seismically active regions. So, like the flat map, here also you have the seismic zone map or seismically active map of the country. So, based on the past seismic history, it is the Bureau of Indian Standards. They have grouped the country into 4 seismic zones. So why 4? Why we don't have zone 1? Because zone 1 is actually, we do not fall into zone 1. That means zone 1 is free from most of the seismic activities. So we are not into that category. So it starts with zone 2. Zone 2, zone 3, zone 4, and zone 5. So even in zone 2, it is named as least active, and zone 3 is moderately active, zone 4 is high active, and 5 is the highest active zone or the highest seismic active zone. So this is a representation of our seismic actually active zones in the country. So these red zones are the areas of concern. So you see entire Northeast India, all the states of Northeast India. Extension is Sikkim only. So it is in zone 5. So that means we often encounter a lot of earthquakes. And why? The why it has to be answered by the plate tectonic activities, where two plates are meeting, and then the fault is flowing right across these red areas. Okay. Then also in Bihar, parts in Nepal, but we are not showing Nepal here because it's a different country. Then Uttarakhand, Himachal, and then also it's going up to Jammu and Kashmir. And then in Gujarat, you see, so Gujarat also encountered a big earthquake, as I will describe a little later. Then the rest of the countries are also shown here. But apart from that, mm, there are some micro faults which are also responsible from some of the um, mm, earthquake activities, and that is why simply by looking at this map, you cannot be sure that there will be not a major earthquake that may come somewhere in these lighter shaded areas, because uh, there are many other factors which determine the seismic activity of the region. But in general, so we may be sure that these are the areas which are of great concern. Okay, we have to a little bit speed up. Uh, so what are the areas? It says zone 5 is the most active, which the whole of Northeast India, north portion of Bihar, Uttarakhand, Himachal Pradesh, JK, Gujarat, Andaman Nicobar Islands. So you see Andaman Nicobar Islands is also falling into zone 5. Okay, so I may get disconnected because it is saying that another 5 minutes. Uh, so let us just uh, go up till the time we can continue. By saying so, so here in the slide, I am showing you the major earthquakes which occurred in a historical time scale in the Indian Peninsula and Indian region. So you see at the magnitude, that is depending on the magnitude, all these earthquakes are more than 8 or 8. That is severe or severe earthquake, magnitude 8. And remember, this is a logarithmic scale. That means from magnitude 5 to magnitude 6, it is not a linear enlargement of the amount of energy. Rather, it is a logarithmic enlargement. And from 8 to 9, so from 7 to 8 is even bigger. So, starting from 1819 in Kutch, there was one with 8, then Assam. I don't know if you know about this, 1897. So, in Assam or in the northeastern India, there were two such major earthquakes that occurred in historical time. So, one was in 1897 in August 12th. It was the time the epicenter was somewhere in Shillong, and then it is recorded by Oldham. He is a geologist. Okay? Oldham was a geologist back in 1899. So after the earthquake, he is from Great Britain, and then in that period of time, he walked, and then he did the intensity survey of the area simply by walking alone in those affected areas. Remember his dedication at that point of time. And after that, he has recorded these incidents. That is why we come to know about the damages caused by that particular earthquake. I am not going to talk about all the earthquakes. And then the major earthquake in Assam, on the other hand, it was in 1950. I think this was in 6. So 6 means January, February, March, April, May, June. So 12th June, okay? And then it is the 15th of August 1950. So if you look at the time period, 1897, almost 1900, and then 1950. So it was a period of around 50 years. So people say that we are still expecting another major earthquake because we are due. That means the time period or the recurrence interval of this major earthquake is around 50 years. So since 1950, we have passed 50 years, and then still we have not, luckily or unluckily, we don't know, we have still not encountered the major earthquake. So you see 8.7, both are huge in terms of energy released. Okay, so this is the source. So late about the other earthquakes, just have a look at this, look at the list, and I'll share with you. Uh, uh, Before we proceed, I think I don't want to go farther into the other parts of the slide because we will not we have a constraint of time. So let us confine our discussion with the earthquake itself. Uh, so the return period, as I said, is about 50 years. So that means in 50 years of time, we may encounter one earthquake. So the hazard, as I said, has a probability of occurrence. That means 1 by 50 is the probability of occurrence. So if you know this probability, you have an indication about the magnitude. So more is the probability, less is the magnitude, or the vice versa. Okay, so the next earthquake was the epicenter was where was it? It is known as the